Good morning, everyone. Good afternoon, wherever you are. Thanks for attending this webinar. We're going to be talking about advanced analytics for higher education in particular. And this webinar is co-sponsored by Pyramid Analytics and Analytikus. At any point throughout the webinar, please feel free to write any questions that you have using the system. We'll spend some minutes at the end trying to go through those questions. If we don't have enough time, we'll answer them later on. So let me start very briefly introducing myself. I'm one of the founders of Analytikus. We're in the space of advanced analytics and analytics in general. We simplify how companies consume data through the creation of data science solutions, which is replicable advanced analytics solutions. Very briefly, I'll present Dee Walker. Whenever he's going to be intervening, he'll present himself. He's the head of channel partnerships at Pyramid Analytics. Tons of experience on this space. And I will jump straight into it. For those of you that stay till the very end of the webinar, we have a very good surprise for you. So hold there, and I think you'll like what we're going to share with you. So what is the agenda today? First of all, we're going to talk about what's going on in the industry, what's happening with data. Then we're going to discuss what is advanced analytics for those of you that are not in the space of advanced analytics and might have some questions on what it is, why advanced analytics or data science or big data or statistics, how everything collides. And then at the very end, we're going to talk in particular about use cases for higher education. We're going to do a demo for one particular use case. And we'll have a bit of a recipe on how can you start your trip or your adventure on advanced analytics. All right, so what is happening in the world today? So there are three industrial revolutions that we've lived. The first one at the end, and this is kind of the historic background that I'm going to give you before we jump into what's happening today. At the end of the 18th century, so humanity was able to harness the power of steam, and with that we created, we were able of putting engines to work. Some companies, some organizations got it, some organizations didn't get it. One example in Boston, a textile manufacturer, Boston textile manufacturer, they got it, and when competition got really fierce, they were able to sustain it. Then the second revolution at the end of the 19th century, big changes happened during those times. Electricity, gas, and in particular one that we're gonna talk is the telegraph. So we all know Western Union. They were ruling the telegraph industry. They dismissed the phone as a viable business. So pretty much they were about to disappear, but they were smart enough. They changed their business model, and instead of being a telegraph company, they became a money transfer company. So they kind of got it a little late, but they got it, and they were able to survive. Then the third industrial revolution, most of us are very we have been exposed to this time, is the digital revolution. Computers were starting to be used, and everything started to become digital. Well, we all heard of a company called Kodak. So by the 1980s, Kodak ruled the film industry. They had about 80% of the market share in the film industry. And as time went by, you know what happened with Kodak, and not very long ago they even filed for Chapter 11. So what is the pattern here? Some companies got it, and some companies didn't get it. Why am I telling you this? Well, because we're in the brink of the fourth industrial revolution. And what has changed? Okay, so data is everywhere. And there are three drivers that are pushing this fourth industrial revolution. The first one is big data. So data is everywhere, being produced by sensors, the Internet of Things, by computers, by every transactional system. So we've been storing data for many years now without really using this amount of data. And the amount of data that is being generated, and I'm going to show you in a statistic later on, just mind-blowing. Then the second one is the cloud. So not only large companies have access to processing power, but now small and medium business companies have unlimited processing power. And finally, intelligence. So data mining is not new, but it was really hard to make the whole process automatic because it was hard to get all these storage capabilities and processing capabilities that we have today. So big data and the cloud allow us to be way smarter and to create intelligent systems to recognize patterns. And this is where the advanced analytics space comes into play. So let me give you a couple of very interesting numbers. So according to IDC, $1.6 trillion are going to be generated to companies that are going to be using data. And according to Gartner, by 2020, 10% of the companies are going to have a business unit that is going to be transacting data. Just think about that. 10% of the organizations are going to have a business unit that is going to be dealing with data. Okay, if I haven't created enough anxiety yet, I have another slide to try to do it. So the time to disrupt is shrinking. So 1920s, the average lifespan of a company at the S&P 500 was almost 70 years. Fast forward to the 1980s, it's 20 years. Today is on average 15 years. And what is expected is that the next decade, only 25% of the companies that are part of the S&P 500 are going to be there. Only 25%. So think about the companies that are there today, no? And those companies that we all heard of, Radio Shacks, Kodaks, that are not part of the S&P 500 anymore. So here's a quote that I wanted to share. The only comparable time to this is the Industrial Revolution. And let me throw another quote here. That is, only those that grasp how data is becoming the new oil will be capable of sustaining their competitive advantage. So every organization has its challenges, and only those that can have an edge in order to compete will be able to sustain the advantage. So with that, I want to welcome you to what we're going to call the zettabyte era. For those that don't know what a zettabyte is, this is pretty much what it looks like. And to give it a little perspective, just think about if we put all the digital information, universal digital information in a box, it would be 10 zettabytes. Everything, 10 zettabytes. In 4 years, it is expected to become 40 zettabytes. Let's see it with a little bit of a visual to help us. So all the digital data that has been created from the very beginning is only 10%. From the very beginning until 2015 is only 10%. 90% has been created over the last 2 years. 90% of all the data in the world was created in the past 2 years. So what is the message here? Where data is everywhere, sensors, every device that you're carrying right now, your cell phone has, if it is a smartphone, it has anywhere between 8 and 15 sensors measuring everything from proximity, temperature. All that is leaving tons of data behind. So how is this data being transformed into intelligence? And with this, I'm going to jump and introduce advanced analytics. So we're seeing on the left side what we traditionally call business intelligence. And traditional business intelligence answers to what happened and why did it happen. But we're always looking at the past. When we're looking at the future, This is what we're calling advanced analytics, where we make predictions and optimizations. And of course, this turns into insights. So let me explain in a nutshell what advanced analytics is. Advanced analytics is a collision of machine learning, data visualization, AI, and statistics. Whenever you hear, what are these data scientists? Well, this is what they do. They do advanced analytics. Without advanced analytics, big data is not really useful. It's just tons of data. But the ability to find patterns, that's where big data becomes really useful. What it's not? Well, it's not traditional BI statistics. It's not owned by anyone. It's not owned by the IT department. It's not owned by the finance department. It's not owned by anyone. And it's certainly not a passing fad. If anything, it's going to keep exploding over the next years. So the same information that I shared with you just a second ago, on the bottom, we have what it's called traditional business intelligence and advanced analytics on the top. As you see, whenever you move into the advanced analytics space, you're getting closer to the decision, and you're simplifying the decision for the people, if you will. You're getting closer to the action, and you're getting closer to the decision through predictives, optimizations, and automations. So have you ever been exposed to advanced analytics and to predictive analytics? Absolutely yes. So every time that you go to your search engine and you type something, well, there's an algorithm that is trying to figure out whatever is most relevant for you. And not only that, all the marketing that it's appearing, all the inorganic text that is appearing, well, that's also part of an algorithm that is trying to predict your propensity to click. So certainly you've been exposed to advanced analytics. So we created a framework to explain advanced analytics and the different use cases. How do they fall in different spaces? So basically we have 4 spaces. The first one is advanced segmentation. So think a little bit whenever you're trying to cluster different populations to understand something, to identify the most valuable students, to identify the most valuable customers. Who of those customers are bringing most of the revenue, are have a certain characteristics that they shared? That would be the first one. That's a kind of an example. Predictive analytics, of course, you're trying to predict future behavior. Prescriptive analytics, you're optimizing different outcomes to maximize a particular variable. And then cognitive analytics, which is something that lately it's been heard a lot. It's whenever it's used actually in 2 ways. One of them is when you're trying to reproduce human-like behavior. Think about vision, think about sound, and I'll give you an example in just a second. But also it's being used whenever you integrate already trained algorithms. So Watson, IBM has tons of already pre-trained algorithms. Same thing with Microsoft. You can look on your search engine for cognitive APIs, and you're going to find a lot of information on this. So at the end, this is a framework, and the different use cases fall into 1 or 2 of these boxes. And this approach is what we call the use case approach. And basically, the idea with the use case approach is the value of big data is in the little data, and you have to have clarity on the question that you want to answer from the very beginning. Otherwise, it's really easy to get lost in the sea of data. So let me talk about higher education now. So we talk about what is going on in the space of data. We talk about advanced analytics. Now we're going to talk about higher education in particular. So in higher education, there are mainly 2 spaces where analytics is having an impact. One is called learner analytics, and the other one is called learning analytics. So whenever we're talking about learner analytics, we're influencing the student's success. And learning analytics is use cases that are very much into the space of influencing the student learning. So remember when we describe what a use case is? Basically, it's what is the question that you want to have answered. And these are some sample questions. Which student is at risk of not graduating or just failing a particular course? Which students have a low engagement? And when we're talking about learning analytics, okay, what is the right content? What is the right strategy for this student to learn? So I'm going to share with you some use cases that we've identified and that we've implemented for some educational institutions. So what we're seeing right now, it's the value chain, not a simplified value chain of an educational institution. We have the student recruitment at the very beginning, student management, evaluation, graduation, then we have the alumni. Throughout the student life, of course, we have the campus management, and then the academia. Academia management, and whenever academia is planning for new courses and programs or diplomas. So I'm going to share with you different use cases. I'm going to, on number 3, I'm going to give you additional detail, but I'm going to describe these use cases from a very high level. If you have any questions, please write it on the GoToWebinar tool, and we'll address them in just a second. Okay, so student recruiting analytics. Basically, you help the institution optimize your recruitment efforts. How do you do that? Well, there are several approaches. One of them is through marketing optimization. So what are the marketing dollars that are converting prospective students into students most effectively? And think on all the different efforts that you're doing. It could be visiting universities, online investments, and traditional advertising. So you support marketing, telling them, this is the ideal profile that is going to have a highest conversion, or these are the ideal channels. And there's another use case that is, of course, marketing mix modeling. Another use case is campus usage. So through the use of sensors, Internet of Things, we can identify the areas within the universities that are being used or not used. And of course, with that understanding, you can customize a little bit the experience for different areas to be more and more exploited. Student retention, we're going to demo this in just a second, and I'm going to spend a couple of slides explaining this use case with a little more of detail. Smart billing. So one of the challenges that universities, private universities in particular, have is you want to minimize dropouts, but at the same time you want to maximize revenue. So there are two things that you can do here on smart billing. One is predict the students that could default, but also if you're going to give them some financial incentives, what is the ideal financial incentive? Smart mentoring. So whenever a student is just setting up the courses for next semester, you could proactively tell the student whenever there's a toxic combination. If most of the student dropouts, for instance, happen during the first year. So if during the first year you include chemistry and mathematics and physics, that might be a toxic combination. So you want to warn the student ahead of time and tell them, you should space out these different courses. Or through the understanding of the performance of the student, you could suggest a specific specialization. Okay, so identification of academic strategies, quantify the impact, classroom analytics. So this is, we've done some proof of concept on this, but basically through the use of cognitive APIs, if you include cameras at classrooms, you can identify the level of engagement for students. And then correlate that with the course, the professor, the grades, and so on and so forth. So this is a little bit of classroom analytics. Besides how many people show up, how many are males, how many females, and what is the engagement level that they are showing. From the student retention, as you can imagine, within a university, the university itself, the retention department, the student success department is the one that is going to be using that model. For the effort index, it goes way down to the professor. And in particular for blended and online courses, it tells the professor whether a student is replicating a pattern based on effort, which is just think if the students are using Blackboard or Moodle, the number of sessions that they are having, the duration of the sessions, the interaction that they are having. So you measure all this in order to figure out if the pattern that the student is having could signal that the student is going to pass or fail a particular course. So an early intervention can take place. Learning analytics has to do, as I described at the very beginning, on understanding the learning habits. And once you understand the learning habits, you could actually prescribe to the student a particular professor given the learning methodology that the professor is using, more on the multimedia side, more on the traditional side, and so on and so forth. So now we're gonna talk about one particular use case. And I want to give you an example. So just think for a second. This is the first day of school. But today you're not a student, you're the dean, and you're going to give a welcome speech to the students. You know for a fact, because this is pure statistics, you know for a fact that 4 out of 10 students are never going to finish. And that number is for the US alone. 4 out of 10 students are not going to finish. So how valuable would it be if from day one you could identify which students are at risk of dropping out? And not only that, what is driving that risk? So that would enable the university to take tons of preventive actions to retain the student and to support the student. So how does it work on a very high level? So we receive an input, let's call it the student DNA, the student profile, their high school, how far do they live from the university. If we know, every university has its own set of data. Even though our set of solutions is pre-packaged and pre-ready, the solution adapts to every university because not only every university has its own set, depending if it is undergrad or specific programs, it's going to be a particular set. So if we know the educational level of the parents, if the GPA of the student, everything that we can know about the student. So we bring that information. This is particularly relevant if we want to assess the risk of new students. Then we bring the student involvement. Whether the student is logging into the university system, if he's getting books from the library, if he's going to the gym, everything that we can get out of the usage of the university. There's, of course, a correlation on whether a student is involved in the university and the risk of dropping out. The payment information, if they are paying on time, late, the payment type, of course, their grades and assistance, if they are showing up or not. So all this information flows into a machine learning model that we have already pre-built that is using different mathematical techniques. And what is the output for the university? For this particular use case, is going to be the student ID, the risk score, and what is driving that attrition. It could be financial, it could be health, it could be psychological, academic, etc. So what have we seen? We've seen a decrease in student attrition from 3 to 5%. As you can see in my screen, on bold, I have the words proper intervention. So there is not a single machine learning algorithm, a single solution that is going to help you retain students unless there is a proper intervention from the university. So let me explain that in a little bit more detail. So basically what we do at the advanced analytics space is, well, we help you define the drivers, we help you predict which students are at risk, but then it's really important to have a solid strategy to communicate with the students and to apply the solutions, whether it's academic, financial, and so on. So I would say that these two are key, and if this solution doesn't work, most of the time it's going to be because there's not a proper strategy to communicate with the students or to apply the solutions. So as you can see, it's not only about statistics, artificial intelligence, and technology. You need the human in the loop. So for a second, I'm going to get a little bit more technical, and I'm going to show from a very high level what is the architecture. So, of course, depending on the use case and the university, you're going to have Banner or Blackboard or Moodle or Salesforce or Dynamics or any transactional system that you're currently using. That's going to feed a SQL server that we have in the cloud. That's going to feed our machine learning algorithms. Then that information goes back to SQL. And then how do you consume the data? Well, the data is consumed from a strategic perspective through pyramid analytics. And Dee Walker in a second is going to do a demo for you. The idea is this is a pain-free solution for institutions to, number one, there are always some pre-built dashboards and some identified KPIs that are going to help you run right away. But also there's some granular information that goes back to the university, which is the student ID, in particular that student ID that could be feeding into the university's CRM, for instance, so you can follow up with the solution, the communication, and the intervention. So with that, I'm going to pause for a second. I'm going to pass the microphone to Dee Walker. He's going to do a brief demo, and then I'll get back to give you some tips on where to start. So, Dee Walker, the floor is all yours.
Fantastic. Thank you so much, Miguel. I think that was really good, really on time. Hello, everybody. Good afternoon or good morning, depending on where you're from. Thanks much for taking the time to join today. Like Miguel said, my name is Dee Walker, and I head up the channel and partnership function for Pyramid Analytics. Many of you on the call today might already be familiar with Pyramid Analytics. We are a company that is headquartered in Netherlands. Our U.S. headquarters is based in Seattle. That's kind of where I am today. And thankfully enough, it's quite sunny out here in Seattle today. In the EDU space, it's not a strange space for us. If you're using a solution such as the Blackboard set of solutions, then chances are you're already using the Pyramid Analytics piece for doing analytics on your Blackboard solution. We are the embedded component that powers the analytics that you're doing with Blackboard. So hopefully you've seen or heard of us. For today's presentation, what I'm going to do is I'm going to take one of the use cases that Miguel talked about. He talked about, I think, 7 or 8 different use cases. And I'm going to focus in on one of those use cases, which is essentially student attrition. A couple of things to keep in mind while I go through this demo. It should take about 10 to 15 minutes, depending on questions. First is, from an architecture perspective, we are a analytics platform, and we provide, as a part of this student attrition prediction solution, the whole analytics platform that extends everything from data ingestion, which is you go and get data not just from those set of data sources that Miguel was talking about, but even a spreadsheet, right? Any data source known to humankind, you should be able to get data from there, create interesting visualizations, create interesting reports out of it, dashboards, scorecards, KPIs that you can build yourself, or we'd be happy to build for you depending on your specific business or use case, and then be able to disseminate this broadly, not just within your faculty and within your administration, but sometimes you might realistically want to take some of this data and present it to your students as well. And we have a fantastic way to be able to do that. So we're a platform. We approach this as a platform. Like Miguel said, there are pieces of this that are already pre-built. We wanted to take one piece that we use as a sample, and I wanted to kind of show that to you today. The solution itself is completely hosted and cloud-based. But if you do need this to be on premises for you, we can try and do that as well. For today's demonstration purposes, I'm going to use a sample, which is a hosted solution. And simply because it is hosted, I am able to connect to it from a browser, right? You can connect to it from a browser, from a tablet, from a cell phone, what have you. So it's very easy for you to start getting up and running with the solution and start seeing value and start consuming the information immediately. For those of us on the call today who are not from English-speaking locations, good news, the demo that I'm going to show today actually is built off of a obfuscated sample that we used in Latin America. So this is what you see today is going to look in Spanish, right? Now, I don't speak much Spanish. My Spanish is probably as good as my Latin, French, and Swahili. So if you're not, if you're in the same place as I am, then I'm going to make sure it's easy for us to follow through as we're going through the demo today. So with that said, let me jump right in. If you're on the same screen as I am, you should be seeing my browser where it says student desertion analysis. Wherever you see the term desertion today, it's the same as attrition, right? And we have a dashboard that is prepared for us. I've started over here with the dashboard, which is kind of the finished product. As we go through the demo over the next 10 minutes or so today, I will drill down, try and show you some of the ways in which you can slice, dice, be able to collaborate with this data, etc. So let's start off with where the dashboard really takes us. Again, keep in mind that everything that you see today is more of a sample. Think of this as a starting point. We can always customize, add, subtract, depending on the kind of data that you have, your specific business use case, and so on and so forth. So the first tab, you can see that my dashboard is split into multiple tabs over here. There is a validation tab. There is a attrition rate per student tab, student details tab, and so on and so forth. And we'll go through these tabs and try and see on this dashboard what is a sample of kind of information that the system can give us. Now for the system today, you would see the set of slicers across. I am on the validation tab. Validation essentially is giving me a high-level snapshot of what is this confidence of the system. You would see these numbers over here in terms of what is the average beta, what is the F beta, what is the precision percentage that the system is giving me. So 0.82 means that the system has a very good, it has 82% confidence in the recommendations that it's going to give you. So it kind of gives you a snapshot of, for the data that you have provided, that you've uploaded into the system that is coming from your, Blackboard or other line of business applications, how much can you trust every other tab that you're going to see over here? So higher the numbers over here, more the correlations we've been able to find, and the better the model has really worked for you. Now throughout this demonstration today, you're going to see a bunch of slicers. The slicers are, for example, the number of weeks, right? So weeks gives you a time-lapse image of data being captured from within your system, right? So for example, week 1 is the first week of operation of a particular semester or a particular season or a particular year. Similarly, week 4, week 7, and so on and so forth. Now, there are two models that we have built for the system. There is a model for new students, which shows up here as new, and there's a model for regular students. Now, the reason that we have these two different models is because typically for regular students, you have a lot more data than you have for new students, right? You know, when they are going into a library and checking out a book, right? And what kind of books they're checking out. You know, what times they use certain facilities like the labs and so on and so forth. So there are tons of data that you can capture for a student who is already enrolled and is a regular student. But there's also data that you can capture for new students, things like their demographic information, financial information, things such as how far away from the college, from the campus are they planning to stay, things like those, right? So two different models for regular students and new students, and you should be able to analyze both regular and new students within your organization. And if your organization spans multiple colleges, if you miss the last 3 minutes, that's because I wasn't showing the screen. But here's kind of how it looks like, right? Like I said, it's browser based. This is the dashboard that we're sharing, that we're seeing right now. Here are the tabs that I was talking about. We're on the first tab, which is a validation of what the system looks like. I was just quickly going through the slicers over here, right? So I talked about different weeks that you could get data in, and you can see that as I change the week, the kind of information that the system, that the artificial intelligence or the algorithm throws out for me changes, right? So the more data we get, the more somebody progresses within a particular course. Obviously, the confidence factor keeps increasing. The confidence factor with the data keeps increasing. You're able to articulate and be able to pinpoint with much more accuracy in terms of what the attrition percentage is going to look like. I was talking about the campuses. If you have multiple campuses, we support the capability to be able to slice, dice, roll up, and drill down across multiple colleges, multiple campuses, multiple courses as well. So on the first screen over here, what you're seeing is, this is a snapshot which says everything that you see in blue are people who are not at risk of attrition. That you see in red are people who are at risk of attrition. And it is split into deciles, right? Deciles are 1/10. So the way you read this is, here is my 10th decile, which is, these are the people who are at most risk of attrition. And there's a risk of almost 55.7% of the students in this particular group to discontinue the course, to have attrition per se. You have at any point in time the option to be able to right-click and then drill into these details, which gives you the list of all the students that make up this particular this particular graph, or this particular segment of the graph. A couple of other interesting views. So that was kind of what the overall system looks like. Let's drill in a little bit more for us to understand what the what the layout is in terms of understanding how student attrition might happen, right? What you're seeing on this screen, this is the attrition rate per student. You have two different views over here. One is a view in terms of what is the score by different campus. You can see that there are 3 different campuses in this particular use case. There's a New York, Orlando, and this one is a Boston campus over here. You can see that the attrition rate prediction for New York is much, much higher than what it is for Orlando or for Boston. So clearly, if this were real data, you would want to double click into New York and try and see what's happening over there. Similarly, over here, from a perspective of different electives, different courses, or different faculties that are being managed within the institution, you can see that there are higher probabilities of attrition in the business stream or in the engineering stream, and you might want to right-click and be able to drill down and figure out what's happening over here as well. At any point in time, you have the capability to be able to dice this data across multiple different risk factors and models that have been created. Again, this is just a sample over here in terms of in terms of the data set that we've used. Your specific data set will depend on the line of business application that you're capturing. So let's just spend a little time with this particular dashboard. We talked about there being a problem, not particularly with Orlando or Boston, but New York has, in this example, a really large prediction for an attrition rate. At any point in time, you would be able to right-click over here, come down and say Analyze Further. So what Analyze Further with each of these graphs, and all components of the dashboard that I'm showing you today has this capability for you to be able to right-click and say Analyze Further. This really brings us into a sandbox, a free-to-use kind of interface where you will be able to slice and dice this by different dimensions and models that are a result of the data that you have. For example, over here we have the probability of people leaving. Let's say on this result set, I also want to throw what is the number of students, right? So let me say number of students. I simply control-click and select the number of students and go ahead and rerun this query. And you will see that now the size value of the box is the number of students. So there are 10,000 students over here in New York, and they are at a high risk of leaving as compared to 3,200 students in Orlando or 650 students in Boston. So if this were actual data and you're running this business, you really have a cause for concern, because not only are there higher probabilities of people leaving in New York, the size of the number of students leaving in New York is also really high. So that's a great way for you to be able to drill down and be able to identify what what that data is telling you, to be able to analyze further. Now let me close out of this and get back to kind of where I was. Let's take a look at some other views, right? Analysis in terms of what the causes for attrition are. There are different dimensions that you can analyze this by. For example, student by students per faculty, the age of the students, the gender of the students, campus, and so on and so forth. There are different dimensions by which you will be able to analyze this. Again, across all of this, it's going to give you a capability to see how many people are at risk of leaving versus not at risk of leaving, right? So you can see a good mix of different dimensions over here for you to be able to analyze your risk of students across different dimensions. We can go one step further from there and take a look at some of the other views over here to see the same kind of risks across age ranges, across campuses, and having the slicers for you to be able to do a drill down analysis on top of that. There are views over here that give you the causes for which are driving attrition. For example, if I were to change this to architecture in Boston with my week 7 data, what this is telling me is that payment seems to be the largest contributor to why students might be at risk of attrition, followed by things like attendance, what their balance is, what are the number of courses that they take, and so on and so forth. Again, like I said, all of these are immediately drillable, sortable. You can click and get into the details of each one of these elements individually. Finally, it comes down to the students, right? So we have a view over here that shows you what the risk of individual students are across your entire student base, and you have the capability to be able to drill down or slice and dice this like every other component that we've seen. So what you're seeing here is the student ID, and it gives you a score, and this is ranked in a descending order of the probability that this particular person would leave, right? Again, like we did earlier, we could always come back over here and change the style of what you're seeing over here. You're seeing a grid. Maybe you want to see a different kind of grid. Maybe you want to come here and analyze this further. I just right-click, go to Analyze Further, and I have all the different capabilities for me to slice and dice this data available to me on the kind of on my selection panel over here on the right. So let me close out of this and get back to the view I was on. The final thing that I really quickly wanted to show you was a look at the causes of people leaving, right? A look at the causes of attrition. There are tons of factors that we model based on. Starting from which high school they went to, what are the courses they elected, what are the type of payments they will do, what's their gender, what's their cumulative GPA, and so on and so forth. And we've taken all these factors and run it through our proprietary algorithm, the artificial intelligence algorithm. And what that comes back and tells us is what are the factors that determine the probability of a student staying or leaving. So in this case, for example, it shows us that which high school they attended has the highest probability or highest correlation to whether a person decides to stay or leave, followed by the number of AP courses enrolled and enrollment days and so on and so forth. So this is a great view from business perspective for you to be able to understand what are the factors that are driving potentially for people to leave. Again, you will be able to right-click and zoom in, let's say, just on this particular thing called high school, because that seemed to be the biggest factor. Go back, analyze this further. Let's say I want to have a different visualization. I want to see this not just as a chart, but I want to see this as a grid and a chart. So I'm going to drop a grid here. I'm going to drop a chart over here. Now I have only high schools. Let's say I want to take a look at what kind of schools these guys come from. So I have a dimension over here called student type R. I'm simply going to grab this and put this on my rows, and immediately I see that if somebody is coming from a government instituted high school, a matriculation school, the way it is called in Latin America, which is if you've graduated high school, then your risk of high dropping out is much larger as compared to if you've attended a private school, your risk of dropping out is lower, right? So this kind of an analysis for you to be able to drag, drop, and quickly visualize your data exists across all of these different views that I showed you. You have the capability for you to be able to create custom calculations on your own. For example, let's say I want to go and calculate my average ratio of students. So I'm simply going to take the total number of students divided by the number of students leaving, and I'm going to create a average function or a standard deviation or a minimum or maximum function or an aggregate function like a median or a standard deviation function or a ratio function over here simply by the click of a button. So with that, I know we're almost up on time. Let me stop the demo at this stage and pass this back to Miguel.
Thank you, Dee Walker. So you should be able to see my screen now. Just some final thoughts. Where to start? And this is a question that we get quite frequently. So from the slides that we shared at the very beginning, you solve the concept of the use case. So the first thing is be clear on what is the question that you want to solve. Once you have that, what is the data that you need to solve that? And then that's where the data scientist is going to start playing. What is the best technique to generate valid, reliable findings? Pure statistics, 70% of the time spent on this is going to be cleaning your data, standardizing your data. So that takes a lot of effort. And then be ready to act on the findings. And this is where it becomes really, really important for you to be clear on how you're going to make this operational. How you, in the example that Dee Walker presented, how your retention team, your student success team is going to contact the students. What are the solutions that are going to be proactively proposed? Of course, use data responsibly. Support yourself with technology partners that you trust and get ready for change. This is a little bit the roadmap that we see on, okay, how do I start? Where do I start? No? So this is kind of a recipe. Now, some final tips. Start small and aim for a quick win. If your organization has not done any efforts on advanced analytics, find a use case that might not have the biggest impact, but it's going to have a quick win. And that is going to set things in motion. Pilot, measure, and repeat. And from the very beginning, think how you're going to make data operational. So finally, let me quote Darwin for a second, and I think it's really relevant for the fourth industrial revolution. It is not the strongest of the species that survives, nor the most intelligent. It is the one that is most adaptable to change. And we've seen history, no? The first industrial revolution, some organizations get it, some didn't. The second and the third industrial revolutions, we're living the fourth one. So it's important that you understand how you need to adapt towards this. So before we end, we told you we had a surprise for you. It doesn't really matter if you're not in the higher education space or actually, Dee Walker, I'm going to improvise this, but it doesn't matter if you're watching this webinar on demand. If you're interested, Pyramid Analytics and Analytikus is going to co-sponsor a data science maturity assessment. And so what does that mean? Basically, we'll help you set the roadmap and to identify the gaps for you to start on the advanced analytics wagon. What is needed? What is missing in terms of infrastructure, software, human skills, and so on and so forth. So if you're interested, just feel free to send us an email. Our emails are right here. I'm going to stop right here for a second. I'm going to leave this slide presented, and if you got questions, it will be our pleasure to answer them right now. So let me see if we have.
I think there was a question around what are the algorithms that we've used for predicting the student attrition?
So basically what we've seen that works best is a combination of multiple techniques. So it goes all the way from logistic regression, random forest, boosted decision trees. And what has worked for us the best is to run the models using all the different techniques and pretty much select the winner. No, it could be neural networks as well. And the one, it might be a different one for new students than for regular students. And it might be a different one if you have different programs as well. We've seen within the same university for undergraduate students and working adults, the models are supported by different mathematical techniques. So there's no one answer. No? It could be multiple.
Thank you. There was also another question, and I'm going to read this out. You talked about the models being applicable to a wide variety of industries. Do you have pricing that is specific to the education space?
I think the best way to approach it would be to understand a little bit more your educational institution. It could vary from university to university, how many sources we need to integrate and so on. So if for the particular person that sent that question, if it is okay with you, we'll reach out to understand a little bit more on what are your specific needs, and we can give you a ballpark really, really fast.
Correct. And if I may chime in on that, I think the way that we've approached this is that we've, it's not just about the solution, it's also about the whole package, right? So everything starting from a seamless way for you to be able to upload data to our hosted site, and, simply because it is hosted, you don't need to worry about procuring infrastructure for going and running this, to the way that it is priced, which is specifically priced keeping in mind that the education space is very, very sensitive to the costs that are involved. We've made sure that it's priced right for this industry. A lot of our customers can stand testament to that. What's more, it also has very, very interesting, very high ROI that really you find it difficult to find with many solutions, right? For example, if you were to stop a student from dropping out or two students from dropping out within an university, chances are you might have already paid for the platform in itself. And we can stop many, many, many more than just one or two students. So it's got fantastic ROI.
Perfect. Thank you, Vakar. I don't know if there's any other question. And please, if you have any questions later on, or if you're watching this webinar on demand, our emails are right there. Feel free to send us a message, and we'll get back to you ASAP.
Thank you. With that, we're at the top of the hour, so thanks so much for joining. Hopefully you enjoyed the session as much as we did in presenting it. There were a few technical delays. Sorry about that, but hope to hear from you if you liked what you saw today. Thanks much, and good day.